without. We started talking about this on last Tuesday, but you guys looked bored, so we stopped.
I know I do.
You know you do?
I have a smaller brain volume.
Well, I know I do too. My hair makes up for it. But, not really. Watch it back there, buddy. Too close to that door, I'm asking you to leave. So, we got anecdotal evidence. Chris says yes, he does. Second anecdotal evidence, I say yes, I do too. Hair compensates for it. But the question is, does it hold up? I've never even heard of this before. This was interesting to me. I mean, being diagnosed with ADHD, I'm like, this is kind of cool. Now, first of all, number one, maybe they have smaller brain volume, maybe they don't. Secondly, does it matter? That's another question we're not going to answer in here. That's more like a psychological, neurological question. So, I don't know how to answer that question, so we're not going to worry about it. Let's just grab some data and see. So check the data there. Very often, I like this one because this data was actually pulled directly out of the article. This is how they will often give you results of data in articles. They won't give you the raw data like it is down below in a tabular form. They'll simply slap article data like this. They'll give you, hey, we took a sample of 152 ADHD kids, 139 non-ADHD kids, okay? So right away, you can tell that this is not going to be a matched pair test. How can you tell right away there's no matching going on here? Different sample sizes. You can't pair up different sample sizes, right? In order to do a matched pair, you have to have a left and a right, or an A and a B, or a before and an after. There's no matching going on here. So this is not going to be one of those ones like the stopwatch or the commercial in the shows. Good, perfect. Not to mention they didn't give you the raw data, which also makes it very, very difficult. Makes it tricky. Okay, so there's that. They also gave you the average of the kids' brains volume. 1,059.4 milliliters for the ADHD kids, and then 1,104.5 milliliters for the non-ADHD kids. So we can stop talking about it right now because yes, they're smaller. They're smaller by 40 or so milliliters. Chris, remember you didn't like that measurement. So we call it cubic centimeters instead. Assuming it's the same as water, which is not the same because it's brain, not water, but whatever. So they measure it in milliliters. Is anybody familiar with why they use that? I don't have a good answer for why they measured it in milliliters. Anybody know? Any neurological folks here? Is that how like ultrasound works?
I know in chemistry that's the preferred measure.
Milliliters versus cubic. Okay. It just seems, it's funny because volume, I think, length times width times height, like a cubic unit,
yeah,
which converts directly to milliliters metric system. So, okay, so chemistry's preferred. We'll go with that. That's fine. Thank you, Elizabeth. So, right, it's smaller. We're done. Game over. Why go further? Why go further? What are we ignoring if you look at the average?
Standard error.
Yeah, and look how big the standard deviation is on these brains. That's what caught my attention. You got hundreds of milliliters of difference over a 1,000 milliliter brain. That, to me, raises suspicion. If those deviations were tiny, like 10 or 11 or 12 milliliters, I'd be like, oh God, why bother even doing this test? You've got a curve here, and you've got a curve way down here. The problem is, I've got two curves that are 40 milliliters off, but the standard deviations are 3 times that difference. That makes me wonder a little bit. Now I have that on one side, because that right now makes me feel the curves are close, right? But then the sample sizes being as big as they do, makes me think maybe they're not as close as I think they are. Because remember what large samples do to curves? What do large samples do to curves? And they have since day one? I had a proud moment in 243 yesterday. For the first time, a 243 student went like this in class. Which means the central limit theorem made sense to them intuitively before the class was over. Makes me happy. For you guys, it's second nature. As soon as sample sizes go up, you do this. So I've got these two things going on, right? I've got two averages that are fairly close with wide spreads, but I got two huge sample sizes comparatively that are going to drive the curves together, which makes my gut confused. Very often my gut can look right at numbers and be like, okay, that's a clear-cut distinction. But this clouds it, because you've got two opposing things. And that's where the t-test comes in. The t-test does it, checks your gut for you. Let's not have our gut checked then. Go to your template. What variable or variables are we testing?
Yeah.
Clearly mu, because we're talking about average brain volume. Boom. Average brain volume. Yes. Now we got two variables, don't we? I think we do. This is the ADHD brain volume. What about two variables, friends?
With and without.
Yes, the average brain, so I'll call them mu1 and mu2. Now this one, we don't have to worry about what we call what. We did mess up a little bit in class last time because we switched the labels on the pre and post. It won't matter here because they're independent. What should mu1 be, with or without?
Without.
Without. So this is the non-ADHD brain volume. Yes, ma'am. Yeah. How about mu2? That's got to be the ADHD brain volume. Yes. Love it. Love it. Everybody understand why we have two independent U's? This is different, of course, than we had before, where we had two measurements of the same data set. So when you measure one data set twice and then look for a difference, that's one mean, the mean difference. We've got two different data sets measured independently. We're trying to see a difference between the two data sets. That's definitely two independent means. Everybody okay with that? With that logic? Hopefully good. All right. Now, let's look at error analyses. What would it, oh, read the hypotheses first. We can do it, we can do errors. What's our claim? Or what's the question posed?
ADHD reduces brain.
Good!
Does.
You got it, you got it. Does ADHD. So in other words, symbolically, what would this look like? The claim would be that?
mu2 is less than mu1.
Everybody okay with that? mu2 is less than mu1. We fair with that? Or mu1 is greater than mu2. Your choice. They both mean the same exact thing. What would the null be? Not that it really is all that important because it's just the opposite. Actually, we'll just fill it in.
Greater than.
Yep.
Or equal
Or equal to. Good. That's the mathematician in me. Very often you'll just see an equals sign in the literature. If you see it at all, very often this is getting kind of thrown off by the wayside and being replaced with just the research hypothesis, which is something to be said for that, I guess. All right. So we run the study, which we haven't done yet. I like, personally, and you'll thank me for this if you take 350 later on at OSU, 351. I like looking at errors first. What's the two ways we can be wrong? Define me the errors. Pick one, your favorite, and tell me what the error would be. Type 1 or type 2. Give me one of them.
Type 1 would be saying it's smaller when it actually isn't.
Boom! Very nice, Chris. Type 1, saying the brain is smaller when it actually isn't. Saying the ADHD kids have smaller brains when they actually don't. Thank you, sir. False positive. Very nice. False negative?
Saying there isn't when there is.
Good. Saying the brains are not smaller in ADHD kids when they actually are. Yes. What's worse in your opinion? Good, and this is one of those ones you might shrug and be like, I have no idea why I would even care about this. So, Sean, go ahead.
1.
One. Tell me why one. Good.
It's a social
I vote 2.
aspect. You label when the kid has a smaller brain than
And that's the thing, right? That's the thing about putting a word like your kid has a smaller brain than a non-ADHD kid. Nobody's bothered to ask the question, what does a smaller brain imply? Right? Nobody's bothered to say, what does a smaller brain mean?
sociological.
Exactly. It becomes sociological, but it's almost like it could be a misguided sociological stigma, because if a small brain doesn't mean anything negative, it's simply like saying he's brunette versus blonde. There's no sociological stigma there as far as I know. But as far as a smaller brain, it almost sounds wrong, right? Because, I mean, years ago I heard that Einstein had a huge brain by comparison to other human beings. And we have this association, oh, Einstein, genius physicist, huge brain. Oh, my kid's got a small brain, therefore blah, blah, blah. I mean, I'm not saying it's legitimate. I'm saying that it could very well be a sociological stigma. You got my vote too, Sean, for a type 1 being worse. Anybody say type 2? It's up to you guys, really. Elizabeth, go ahead.
Oh, the type 2's bad too, but I definitely agree with 1 would be
Sure.
more damaging to the kid.
Sure, any error is going to be bad because you missed what you're looking for, or you said something was different when it wasn't. The question is, some of these questions of whiches could be worse and why is dependent on what you're studying almost, and what field of study you're in. Okay, beautiful. I think we're done the part as much as we can do without actually running the test. So, since type 1's the worst in our votes, I think we'll leave it at 95% confidence. Which distribution? Definitely T, because we're talking about averages. We need a test statistic and we need a p-value. Some people will tell me, let's just run 2 t-tests. one for the brain volume of ADHD kids, and one for the brain volume of non-ADHD kids, right? Just run two different t-tests. What's the problem with running two different t-tests?
You lose confidence.
Be beautiful, thank you, Aaron. You have to go back to your first exam, which I know you've already forgotten. You filed it away, you've kicked its ass, and it's gone. But if you run too many tests in a row, you sacrifice confidence with each additional test. So running two tests at 95% confidence, you're down below 90% confidence, or right around 90% confidence. So that's why the two sample t-tests will do a very nice job for us by running both together. It looks at the difference in the two averages and compares that